session. Okay, so this over here, it's totally an interactive session. Whatever you have, just let me know. I will clear it out. I will clear your doubts, everything. Right. So just the first question that I'm going to ask you is, what is embedded system? Just let me know in the chat box. Okay, so let me tell you, the embedded system is nothing but when we call embedded system, you can say as a chip or a plate where every unit, ICs, resistors, everything is embedded on a single board. That is what we call as an embedded. Okay, and when we use such systems to control things, we call it universally as embedded system. Right. So this is what the definition of embedded system says in simple. Now, if you go and Google and what is embedded system, it will give you a lot of huge definitions, book-rich definitions. But the actual definition is things that are embedded on a single plate, that is known as embedded system. Okay. So now embedded system is a vast thing. We have every IC, microcontrollers, microprocessors, all are under the embedded system. So it is a vast topic, embedded system. Inside embedded system, we come under the smaller version of it. That is, there are Arduinos, there are Node MCUs, there are VMOS, and many other microcontroller boards through which we could control. So in this session, we're going to use basically two kind of boards. One is Arduino, okay, and the second board that we're going to use is Node MCU. Okay, so you must have heard of both the things or may not. Arduino is more popular than Node MCU, but when we go for the Internet of Things thing, then Node MCU is the board which we will be using for controlling things over Internet. Right. Now, if we go with the what is Arduino, so I will just share my screen once so that it is compatible to you. Just let me know if my screen is visible on the screen.
Yeah, it's visible.
Just let me know if my
Yes, sir,
screen
it's
is
visible.
visible and let me know in the chat box.
Yes, yes, sir. It's visible, sir.
Okay. So see, Arduino is a microcontroller, okay, through which we could control devices, okay, we could control things, but not over internet. Through Arduino, we cannot go over internet with this board itself. For going over internet, we need to integrate some of these modules with it so that Arduino is also compatible to go over internet. But with Arduino board, we cannot go over internet, right? Now the thing is, uh, now the basic question, second question that I'm going to ask and clear you all, that do you know the difference between a microprocessor and a microcontroller? Just let me know. If you know, just uh, just let me state it in the chat box. Then what is the difference between a microcontroller and microprocessor? You have 15 seconds with you.
Sir, can you please repeat the question?
Okay. So I believe you don't have a clear view of what is a microprocessor and microcontroller. Now the thing is, when we are able to control only one thing at a time, okay, or one task at a time, that is basically microcontroller is. Now what is a microprocessor? when we are able to control multiple tasks at a time, that is a microprocessor. For example, you are using maybe a system, maybe a smartphone, maybe some other devices which are smart. So those devices we use multiple tasks at a time. That means those devices consist of a microprocessor. We have i5, i7 in the system, Snapdragon, then you have AMD in the smartphones. Okay, so these are the microprocessors. Now, when we come to the microcontroller, that is basically made to control a single task. For example, TV's remote, that is a microcontroller. It will control only the TV, AC remote, or any other things like Arduino. Arduino is also a microcontroller because whatever thing we're gonna type, means we're gonna code it to control, it will control those many things only. It won't go for multiple tasks, right? So this is the basic difference between microcontroller and microprocessor. Now, coming with the basics of it, Arduino actually. So if we go with the types of Arduino, what are types of Arduino we have? So you can get, we have Arduino Uno. Okay, this is the means the basic board that we use it basically. So I will go with the images first. See, this is the Arduino Uno. You can see it. Okay, it has a Atmega 328 microcontroller into it. Okay, so now if we go with any other type of board, like we have Arduino Nano. Now what is the difference between Nano and Uno? Nano has less number of digital pins, means pin. You can say it has a less number of processing part. Okay, it is a smaller board. Okay, it has less number of pins, less number of processing power. Everything is less than Arduino Uno. Similarly, we have a bigger version of Arduino Uno, like we have Arduino Mega. If you search for Arduino Mega, you will find, see this, it has more number of pins, almost 60 digital pins, 54 to 60 digital pins are there. Some analog pins are also there. So many number of ways where we could control more number of appliances with a single board, and it has a more powerful processing unit. Okay, controlling unit. Now similarly we have got the types of Arduino. Now where we use what type of Arduino, see there is no difference in the programming of Arduino. Okay, the programming is similar for Node MCU too. Whatever programming we do for Arduino, it is almost similar for Node MCU board also. So the thing is, we will learn first of all the basics. We'll clear out the basics of programming in this particular session with Arduino, and then we will apply the same codes with some uh, integrated part of Internet of Things. Means using internet, we'll just integrate it and we'll use those same codes using Node MCU. Am I clear? Just let me know if you understood till over here, if the concept is clear to you. Just let me know in the comment section. If you have any doubts in between these sessions, or if you have any queries, just put on your queries into the chat box so that I could clear your doubts anytime whenever I reach to the topic, right? So now, where do we use these boards? Now I have shown you Arduino Nano, I have shown you Arduino Uno, I have shown you Arduino Mega. Now there is many other boards like Arduino LilyPad. Okay, so LilyPad is something that we use usually when we use gesture control things, like when we move our hands, the other device should also move. For example, there is a vacuum cleaner. Okay, and when we move our hand left, the vacuum cleaner should move left. When we move our hand right, the vacuum cleaner should move right. When we move front, the vacuum cleaner should move front. When we move our hand backwards, vacuum cleaner should move backwards. So these are the gesture control mode that we put on, and it is very much easier with Arduino LilyPad. Now every board has their own benefits as well as demerits also. Okay, and you should know which board should be used or which suits more to your particular project, what you're going to do. Now the thing is, how you're going to choose it. For example, you have a project of a blinking LED. You have nothing to do. You have taken 3 to 4 LEDs and you are making a pattern out of it. That's it. So now doing such a simple project is very much simple and you have a less space. So the most preferred board is Arduino Nano. Okay, I repeat, there is no coding change. Only the thing is, as per your project requirement and processing power requirement, we use a board. Now you have 3 to 4 sensors. Okay, now you need to integrate those sensors into a board. Excuse me. So how you will integrate that? So you will use a higher version of Arduino Nano. You can do it with Nano also, but if the coding part is much more complex and heavier, then we switch on to the higher version of it, that is Arduino Uno. Okay, for basic project and all, we always use Arduino Uno. Now, when we have a heavier project, for example, you are making an attendance system using a fingerprint or RFID. Now, you have seen a boards where cards are also acceptable and fingerprints are also acceptable. Plus, some other securities also have that 3 systems. You need to swipe a card, you need to match your fingerprints, as well as you need to match your retina. Okay, in the eyes, you need to match your retina. Then only it will allow you to open or do whatever it is programmed to, right? So these all are complex, heavier programming part, and it will not be accomplished with Arduino Uno. So for this particular thing, we have to go with the higher version of it, that is Arduino Mega. Are you getting my point? So the thing is, as per our project requirement, we choose our boards. Okay. Now, if we go with the details of Arduino. Now, first of all, I will show you before going to the what is how Arduino going to each and every pins of Arduino and knowing what is Arduino all about. I will first of all go how to write, where to write code of Arduino. Okay, so we will first of all write Arduino, and when we write Arduino, we'll go with this website arduino.cc. This is the official website of Arduino. Over here, we'll go to software. We'll go to software, and we will download the software as per requirement. See over here, you will find Windows 7 and newer. Okay, Windows 8.1 or 10 application if you want over here. Then we have Linux right over here. So these are the things that we always go with. If you have Mac, you can go for Mac. So as per your requirement of the system, you can install Arduino. Right. When you install Arduino, then the process is very simple. You need to just put on the path where you want to install it. I'll just show you. Okay, for example, I'm just going for Windows app 8.1. Okay, you need to, after clicking this, you will just need to just download. When you put on just download, it will just download it. You need not to pay all this. This is for if you want to contribute anything to Arduino. Okay, if you want to contribute anything to Arduino, you need to pay this. Now, in few minutes, you will your app will get downloaded, I believe. Yeah. In few minutes, your app will get downloaded automatically. Once it gets downloaded, you need to install it. Once you install it, you will find an icon like this over here. You can see like this icon you will find, and you can open this. Okay. When you open this, it will just show you something like this. It will be initializing the packages. Okay. Just preparing the boards, and now just starting. We'll wait for a few seconds more. Okay, so I will just go with a new window and close this one. Okay, so this is what you will find when you go with Arduino. Means install Arduino and open it. Right. Now, over here we'll find some void setup, void loop. This is the structure of Arduino coding. I repeat, this is the structure of Arduino coding. We'll go with the brief of this later on in this session. Okay. Now you will find files where you will find open, save, everything, all the preferences, everything. We'll just go with the details when we are designing with the Arduino structure. We have sketch tools, how to use tools, there are board managers and many other things that we're going to learn way to way as we proceed in this session. Okay, so for now I will just go and open Arduino, and I will show you means describe you the pins of Arduino. Right, so here we opened an Arduino board. Now over here, see properly. When you open this Arduino board, is it visible properly to you? Just let me know in the comment section that you can see each and every pins of this Arduino properly. Just let me know, or else we'll zoom it out a little more. Okay. Now this is no. Let me start with this. So this is this particular thing. You could wait a minute. I will just have a pen with me. Yeah, this will be more clear to you. Now, when we go with this is the way that we connect Arduino with our system. Okay, you can say this is a way where we could pass on the data from a system to Arduino and Arduino to a system. Okay, input output path between our system and Arduino. And also it could be stated as a power supply of Arduino. Okay, now this is an this power supply we usually give through you can give through system, you can give through your power banks, or you can give through your adapters, power adapters, chargers and all. Now over here, this particular pin is the external DC power. Like you use a DC jack to power up. For example, you can use 9-volt batteries, okay, 5-volt batteries. It's upon your convenience, whatever you're using. Right. Now over here you will find a pin, and this pin is a reset pin. Okay, this pin is a reset pin. Now according to you, reset sends in two ways. Like whatever codes we write, when we hit the pin, it gets reset. Okay, the codes get omitted and this board becomes with no code. Right. And other sense of reset is when we press the pin, the code starts from the beginning where it started. Now this reset pin does the same thing. It starts the code from the beginning where we started. Right. So this pin have the same particular function. So whatever code we write, if you want to reset it, means start from the beginning, we just hit this red button over here, which is a reset button. Right. Now over here you will find from 13, okay, to 0. So all in total we have 14 digital pins over here. Okay. Now what are digital pins? And over here, before going to this, you have 6 analog pins. Now we have 14 digital pins and 6 analog pins right over here. Now, before going to what is digital pin, analog pin, I would love to know, do you know the difference between digital and analog? Just let me know in the comment section. Do you know the difference between digital and analog? Okay, I believe you are a little confused with the way what is digital and analog. So let me clarify you. First of all, we'll go with analog. Now, what is analog actually? Analog signals are like sine waves. Okay, so it has no termination. For example, like over here we can have a value of 100. Over here there may be a value of 200. Over here there may be a value of 500. Okay, according to the requirement, analog sensors value to be set. Okay, it basically analog sensors value vary from 0 to 1023. Okay, analog values vary from 0 to 1023. Now, what about digital? Digital values are only in two particular state, either true or false. That means either 0 or 1. There is no in between path. Okay, so it is more secured way of data, digital one. Analog is less secured comparatively, but both have their own benefits, right? What are the benefits? Like where we there are two types of sensors, which one is digital sensor, which follows the digital method. One is analog sensor, which follows the analog method, right? Now both sensors are used till now. Why? If I'm telling that digital sensor is more secure than analog sensor, till now analog sensor is used. Why? What is the reason? The most reason is where we require a range of values. Over there, digital sensors will fail. But where we don't require a range of values, only read either true or false, their digital sensors are the best sensors. For example, I told you that motion gesture using Arduino LilyPad. So when we use a gesture control, we cannot only have a digital sensor over there, because if we have a digital sensor, then if we put our arms left, it will continuously go left. If we put our arms right, it will continuously go right. But if we want to have some speed control, like if we move our hand a little left, it should move in a speed of 20 kilometers per hour. If we move our hand a little more left, it will go to the speed of 30 kilometers per hour. But with digital sensor, this is not possible. So for using this type of methodology, we still require analog sensor in the thing. So over here you can see we have 14 digital pins which will only read either 0 or 1, and we have 6 analog pins right over here which will read a value from 0 to 1023. When we have a digital sensor with us, we connect those sensor digital pin. There is only one digital pin. You always remember every sensor has 3 pins. One is 2R for giving its power. One is positive, one is ground. Okay, supply, two goes for supply, and one is the pin which gives out the data out of it. Okay, and that is called the data pin. So those data pins are connected into this digital pins, right? When we will do practical, we will you will be more clarified with this, which pin has to be connected where. Now the thing is, when we use an analog sensor, the data pin of the analog sensor will connect it in this analog pin. Now, how to supply to those sensors? We have two 5 volts over here. Okay, now we have one 3.3 volt over here, 2 grounds over here, 1 ground over here. Right over here there is 1 ground. You can see this is the ground. Okay, And if you require more number of 5 volt, then over here means this pin is 1 5 volt, this is 1 5 volt. Okay, here are two 3.3 volts, and over here we have 3 ground pins. Okay, now out of these 14 digital pins, you can see over here 0 and 1 where we have written TX and RX. Now what is this TX and RX? These are actually special purpose pins which we generally avoid using for as a normal usage of digital pin. Okay, why? Because these pins are usually used for transmission and receiving serial data. Like if we use Bluetooth, if we use serial communication, we connect two other Arduinos all together. Okay, so for transmitting or receiving data, these two pins are used. So that is why in general purpose we try to avoid TX and RX pins or 0 and 1 digital pin. So we always start using pins from starting from 2 to ending till 13. Okay, so till now whatever I explained, is this clear to you? Just let me know in the comment section. Yes. Okay. So now we have over here, this is the processing unit or the controlling unit, the microcontroller at Mega 328. At Mega 328. Okay. Now what at Mega 328? Now any company will name anything. Okay. I believe it is clear to you. I will just write it over here so that it is visible to you. At Mega 328. Okay. Now if any company makes any product, so if it is naming it, it has a meaning of it, right? So AT symbolizes atmel. Okay, AT symbolizes atmel, the name of the company. Okay, 32 is the means you can say the storage capacity. 32 it has the storage capacity, and 8-bit it is the you can say flash memory. Okay, 8-bit RAM in other words you can say, but over here we use the word flash memory. Okay, so this is what and mega is this board works on megahertz. There are two frequency over here. Over here you can see 12,000, that is 12 megahertz frequency, and over I'm not getting the other one. There is another frequency bit, that is 16 megahertz. I believe it is not there on this particular board, but it is actually there. Okay, you will find two frequencies. One is 12,000, one is 16 megahertz. So this is what at Mega 328 symbolizes. Right. So I hope the structure of Arduino board is clear to you. Now when we move to other part, like to the Arduino over here, so I will just clear this. Now coming to how to write a code in Arduino. Okay, so let me explain you the structure first of all. So the structure of Arduino symbolizes void setup and void loop. Now what is it all about? Now whatever thing in a code we use only once. Okay, we run once, that we write into void setup. Like what all things we write once? Like we write how the means how the material pin should work, either it is input or output. These all things we always use this only once, and that is what we write in void setup. Now, what we write in void loop, according to the word loop, you can understand it will repeat continuously. Okay, so what we write in void loop is actually the entire code. For example, if you want to blink an LED, so we'll start the LED, we'll stop it, again we'll start it. Okay, again we'll stop it, again we'll start it. So this continuous process that we write in void loop. Okay, so I hope till over here you understood whatever we had. Okay, if you have any queries till over here, just let me know in the comment section. Okay, so now for today, whatever we thought that to explain you regarding this the basics of Arduinos, we did it. Now from tomorrow, we'll start up with the projects. Before going to the projects, we'll go with the simple codes so that you can understand what is the structure, how the structure is going on, what is the looping and everything. Right. Now, if you have any queries from your end regarding the IoT, Internet of Things part, just let me know if you have any of the doubts. Uh, Understood your question, Sankar. Are you asking that are we going to study parts of motherboard, or what are we going to study into the parts of motherboard? Means it's a question that are we going to study, or you're asking that what are we going to study? I'm just confused with the both parts. Just explain me that are you asking that are we going to study with the motherboards? Yeah, see, Sankar, I just whatever I just understood about your question is your question resembles that are we going to study the parts of the motherboards and what are we going to study into it, right? So we won't go deep into the part of the motherboards, okay, but we will study how to program those motherboards as per our requirement. Are you getting me? If you got me, just let me know in the comment section. Yeah, very good. Any other questions? See, one thing that I left, I mean, I missed out is that uh, whenever I explained you the digital one, right? What is digital sensors and how it works with 0 and 1. Now, into this entire session, if we use the terms 0, okay, just note it down somewhere so that you could see it. Okay, or else I will just share my screen once more and let me write it down so that it's clear to you. Okay, so if we use the term 0, okay, or ground or negative, okay, these all resembles the same 0. Okay, these all resembles the same 0, or else we say 0 voltage, 0 volt. These all resembles the same 0. Now if we use 1, or we use 5 volt, or we use VCC, or we use positive. So these all things resemble the same, that is one, or you can say positive supply. Okay, these all resembles the same, that is one, or you can say positive supply. So wherever it is written VCC, that means you need to connect it to the 5 volt supply. Wherever it is written ground, that means you need to connect it to the ground supply. And what is ground resembles? Ground resembles 0 volt. Okay, I hope this is clear to you. Yes, very good. So I hope there is no other questions from your end. So as I told, today's session will be short and relevant to the topic about the explanation. Okay, you have a doubt, Nikhil, just let me know. You got an email for Visual Studio. Okay, maybe it is a cross mail that you got. These mail was basically for the web development students, not for you. So maybe there may be a misunderstanding. I will just go through it once and will let you know why you have got. No, this mail was for web development student. If you have installed it, just uninstall this part. This is not of your concern. You just put your systems installed with Arduino, your software, because those Arduino softwares are very requirement for your particular thing. Right. We'll go with many of the things that maybe you cannot do right now if you don't have the components, but we'll try that 60% of the things you could do without the components. That is our main thing that we're going to try, and we will let you know 60% of things that you could do practically without the components, but few things that you require some of certain components, but you can learn now, and when you try to buy those components, get those components, you could go for those things, right? So most of the things will be virtual, but few things that cannot be virtual, because if it is virtual, you can't get understand them. So we will have it in a physical demonstration project, right? Is there any other doubt that I could clarify you? No doubt. Okay, guys. So thank you for today. Okay, today's session was short enough. I know this, but tomorrow the session may go 1 hour or exceed 1 hour also. Okay. So tomorrow you need to have your copies with you, because whatever codes we do right over here, you need to put it on a copy. See, you will get the recorded sessions within 20 hours of the session, but the thing is, sometimes it exceeds 20 hours and you may not get the time to practice if you wait for the recording session. Okay, so put down your copies with you for tomorrow. Thank you.